In this example, we're looking at a fixed volume tank. It starts out with a mole of nitrogen at 1 megapascal pressure, 315 Kelvin. And then what we want to do is add a mole of carbon dioxide to the tank at the same temperature. And the question is, what's the final pressure under two possibilities? Both the gases are ideal or the gases are not ideal, and we're going to model them by the Peng-Robertson equation of state. So let's look at the case where the gases are ideal. Substituting the ideal gas law for these conditions: 1 mole, 1 megapascal, 350 Kelvin. Calculate a volume, 2,619 cubic centimeters. Now that's independent of which gas we put in the system. So that's a mole of CO2, a mole of nitrogen. So if we have 2 moles and we keep the volume the same, then we have twice the pressure. So the pressure then will be 2 megapascals for CO2 plus nitrogen, each 1 mole. That's ideal gas. Because there's no interaction between the molecules and ideal gas, and so in the sense of CO2 doesn't know the nitrogen there, nitrogen doesn't know the CO2 is there. So let's look now at the Peng-Robertson equation state. I've plugged into a spreadsheet for that. So first, let's start out with nitrogen. So we'll start with the same volume, so the same tank, if you like. And now we're going to add a mole of nitrogen at the start. Well, its pressure, not quite 1 megapascal, but pretty close. So this is really close to ideal for nitrogen at 1 megapascal pressure. Now, if we add 1 mole of CO2, keeping the volume and temperature same, calculate the pressure. Well, 1.923 megapascals. The attractive interaction between molecules lowers the pressure in the system. And so if we were to look at, for example, just a simpler non-ideal gas, the van der Waals equation, pressure plus some constant related to attractive forces over the volume per mole. Well, as the volume per mole becomes smaller, and it's become smaller because we have 2 moles in the same volume, right? So the volume per mole is smaller. And this term is larger, and to satisfy the same equation, the pressure is lower, and that's what we see. Attractive interactions cause the pressure be lower. Now, CO2 has more interactions. If we just had 1 mole of CO2 in the system, no nitrogen, the pressure would be lower than that for nitrogen. But notice this pressure plus this pressure does not add up to this pressure, right? The pressures aren't additive because as you go to higher pressures, volume per mole goes down, this term becomes more important. So the difference between ideal gases and real gases.